actually we have one more way by which we can prove the result. Let's see that way. If we consider these terms, k cube minus k minus 1 whole cube, what would it be? So let's see k cube as such. When you simplify this, open up the identity and simplify the terms, you would have this term. So basically this identity becomes k cube minus k minus 1 whole cube. This is equal to 3k square minus 3k plus 1. Now we will make use of this particular identity and we will substitute different values of k. Why we are doing this? You'll see this in a moment, because we wanted to reach at our primary result, which is what? Which is this particular result. So let's see how do we reach here at this particular point using this particular identity. So we are using this identity. We are first of all substituting k is equal to 1 into this expression, so that we would have 1 cube minus 0 cube. This is equal to 3 into 1 square minus 3 into 1 plus 1. Similarly, substituting 2, 3 and so on up to n, we would have these many equations. This one, this one, this one, this one, and in total they are k equations, n equations, right? So what we can do, we can add all these n equations together, so that the left hand side would become 1 cube minus 0 cube plus 2 cube minus 1 cube plus 3 cube minus 2 cube and so on up to n cube minus n minus 1 cube. So this is what is our left hand side, and the right hand side would become, let's see our right hand side, it would be, you can club these terms together because we are just adding. So when you club these terms together, you can take 3 as common, so you are left with 1 square plus 2 square plus 3 square up to n square, right? Then you can club these second terms, minus 3 into 1, minus 3 into 2, minus 3 into 3. Because we are adding, we would have minus 3 into 1, minus 3 into 2, minus 3 into 3 and so on, right? So you can take minus 3 as common, which is what I have done over here, and you would be left with 1 plus 2 plus 3 up to n. So this is the term you are left with. And what else is left over here? Let's have a look. So when you are adding, you are left with this one, this one, this one, and how many such ones are there? In total we have n equations, so there would be n ones. So we are adding 1 how many times? N times. So this term would become just n, right? And you know the sum of first n natural numbers, you have just studied the formula, is given by n plus 1 divided by 2, right? And here actually now in the left hand side, you see this 1 cube and this 1 cube gets cancelled, 2 cube and 2 cube gets cancelled, this 3 1 would cancel with the 3 here. Similarly, this n cube would cancel with the previous term here, so you are only left with the terms n minus 1 whole cube and minus 0 cube, right? I'm sorry, this n minus 1 would get cancelled with this term here, right? So you are left with n cube minus 0 cube. So this is n cube minus 0 cube in the left hand side. In the right hand side, it is 3 into this term minus 3 into this term, you have written it like this, plus n. Now we are interested to calculate what is this term, right? This is the goal here. So what we can do, we can shift every term on the left hand side which is not required for this one. So you can shift this term to the side, it would become plus. You can shift this term to this side so that it would become minus, and you can divide whole thing by 3. So we have this n cube, shifting this term here with a positive sign, shifting this term here with a negative sign, right? And this whole term as such over here, right? So let's simplify the terms further on. Next, what you can do, you can shift this 3 as well onto this side, it is 1 by 3. Then you can take the LCM of these terms as 2, right? So this 2 is here, and then so this become 2n cube. This would be 3 into n plus 1, right? And this would be minus 2n. So you can further simplify this. So when you are simplifying this, it would be 1 by 6, right? So this would be as such, it would be 3n square, and it would be 3n minus 2n, which is plus 1n. This is our term, right? The right hand side is as such, and we are interested to calculate its value here. So when you simplify it further, you see you can take n outside, so you're left with this quadratic equation. You can factorize it and take you can calculate its factors here. So you see we got our solution. So the sum of square of first n natural numbers is given by the expression n plus 1 to n plus 1 divided by 6, and this is what we wanted to calculate here in this particular case. Hence our result is proved in this particular case. So I hope you understood this result well with its proof. Well, that is it for this video. Thank you for watching.